So anyway, thanks for coming to the talk. I hope you, one of the comments I'd gotten yesterday from my training was that was really good actionable information. So I'm a big advocate for talks that have actionable information, meaning whatever we teach, whatever I teach at least, we should definitely make it a focus and an objective so that you can leave here going, I can actually go back to work and do that. And that's really my goal. So with this talk, unfortunately, in the course of my last employer, I had already accepted an offer before this occurred last Thanksgiving. And so I did stay with them all through the point of getting this contained and beginning the cleanup, or at least we had it completely isolated so we could start the cleanup, and then it became my buddy's problem. But I was there long enough to document everything that occurred. And so I'm going to share that with you in regards to how, I'll tell you a little bit about the Chinese APT that we're talking about, but also how we went about finding it. Now, for those of you who don't know, I do the logging training, and yes, I'm a blue team defender ninja and a malware archaeologist. I would like have to talk to me about that later. And yes, my name is Michael. I'm a logaholic.
Hi, Michael.
You're better than my training class was. So, you know, I love properly configured logs. I teach a lot of people about logs, and they tell us who, they tell us what, they tell us where, when, and hopefully how. Obviously the why, we can, you know, discuss that and debate that all day long. We got an interruption of the feed. Okay, there you go. And I think I'm the creator of the Windows logging cheat sheet. That's a real important component to this talk. So that's a resource for you to take away. You can Google it and or just go to malwarearchaeology.com and get it. I am coming out with a Windows PowerShell logging cheat sheet. Thanks to Ben 10, though, that some of his little hackery of launching PowerShell without using PowerShell.exe, I got to go update it. So thank you, Ben 10, my internet con son. And then I also recently at SplunkConf, it's a long story, in Dallas DFW. I also just released at SplunkConf the Windows Splunk logging cheat sheet. I got a lot of requests because I talk about using Splunk in the course of many people I've worked with. And they say, well, do you got some short list of things that start me off so I can kind of get an understanding? That's what this is for. This is about 6 pages. This is, I think, about 5 pages. And then a huge component of this talk in regards to understanding how to start looking for advanced attacks is what I call the malware management framework. The idea here is everybody knows what vulnerability management is. We get alerts and notices from vendors, we read some of the vendor reports, we possibly take action and eventually patch the system. So it's something that generated from a vendor, the information in it causes us to take an action. Malware management's the same thing. I read the APT reports from eyesight partners that wrote up Target's breach in January. I then make a lot of fun of Home Depot, who got breached in July later that year because everything they needed to know was in that January report. And I read those reports and I pull the artifacts out, thus malware archaeology. We collect artifacts of ancient mankind, malwares written by man, malware artifacts, right? And basically you take this information and you compile it and you start improving your active defense. Am I looking for this thing in this place that this APT did? Am I looking for this artifact, right? Some people call them IOCs. A lot of people think IOCs are MD5, so I don't use IOCs for that reason. But malware management framework is, when I want to tweak tools, I read these reports, I see that they're starting, let's say, use the Windows font directory, and so I'm going to make sure I monitor the Windows font directory for creation of new or drops of new files. Doesn't matter what type, for example. And this is really beneficial. On the website, malwarearchaeology.com, there is a link of resources where there's a whole lot of these I've collected. And so if you want to start that concept of reading those and get to understand stuff, highly recommend it. I'm also the co-creator of LogMD. It was a tool we discussed yesterday in the training. I'm actually going to show you a little bit about that at the end, just a couple of screenshots. The idea was I infect malware in a lab, or I have to rebuild the malware, like from this attack, into a lab, make sure I know everything it's doing, so when it comes time to pull the switch and get rid of the malware and, and remediate the problem, I know everything I know. And that gives us high confidence level. I needed a faster way to gather some of that data. And so Brian Betcher of Breaking Down Security and I basically wrote this tool, dumps out a spreadsheet of all the data within the logs. It's going to do some more, and it won't run until you actually configure the logs based on the Windows logging cheat sheet. So there's a tie-in between the tool and the cheat sheet. And it will drop you out a nice audit report that lets you see what you need to set, and you would actually go through and set all these things when you finally do the tool run. So with that, what is the goal? Interaction. There are some things in here you probably want to ask a question on. So if it's something I can shortly respond to, don't be a ding-dong and not ask questions. The only stupid questions are unasked ones. If you ask a good question, and it's really quite appropriate to enhancing the content, Sam will, because now I lost a hand, send you out a ding-dong to encourage you to ask questions. So don't be a ding-dong. And again, learn how us ninjas do it so you can do it too, and I'm going to expose you to a new tool which really came out of the fact of I need to catch more of this stuff. So with that, why listen to me? Well, how many people here are familiar with the gaming environment, MMOs like League of Legends, stuff like that? That industry has been attacked by a group called WinNTI for probably about 5 years. That's what they label them, Kaspersky labeled these guys. That's where that comes from. And this report came out in April 2013, right there. But we found this malware in 2012 and met with the feds, shared them that information so it could get declassified and shared with other people. There's a good chance that Kaspersky got a lot of the information that they needed for this report from us, but they didn't contact us. I kind of ripped Eugene about that one because they missed some things they really needed to be in that report. And the other thing is, the talk I'm about to tell you about, we gave an infected VM to one of the big IR firms, and no, I'm not going to tell you who, because it doesn't matter. Everybody has a bad day, or 3 or a week, or however long it took them to fail in this one. But because I do respect the firm, they do a lot of good work. But the point here is you must validate, or at least have some understanding of what you're giving these IR firms, if you're doing what we did. Give them the image and say, hey, what do you know? Figure out what you know about it first, so when they come back with a report, it aligns with what you think and hopefully expands on what you know. So that's just the point there. So yeah, we find it before they do the reports, and we deal with a lot of IR firms and the Bureau to share and declassify information. So WinNTI 2014 was a much more sophisticated version of this particular Kaspersky attack that we got. They updated their approach quite a bit. For example, 2012 used new services, much like the Black POS did at Target and all the other retailers, installed 2 services. The WinNTI guys installed lots of services that are different across a lot of systems. They didn't do that this time. So suddenly they now know we know to find new services, so they had to change their MO. As we evolve, they evolve. And so we really have to up our game and suck a lot less. But boy, did we catch them in the act. This is definitely not your typical ponage. I hope to really get you guys your eyes open with this information. But boy, the whole 210 days mean time to detection, it's more like 210 minutes for where we're at. I can pretty much get something going within that first hour if those systems are monitored. And in this gaming environment, every system was monitored. So we caught them right when they started. Again, they can infect an entire environment within an hour or two. Whereas it takes us an hour or two just to evaluate one system, right? So they're way faster than we are. And the goal here is, I want to share this so you can learn, okay? Clearly, we have people in DC that are very interested in this kind of detection, I'm hoping, or maybe avoidance of this kind of a detection. It all depends on your perspective. So the history. Again, I mentioned it's been around for about 5 years. It's known that they're Chinese hackers. Both Kaspersky obviously mentions this in their report, so let's believe them, but also the feds told us that they're a known group that's being tracked. But again, they're in China. They attack the gaming industry, and everybody's like, well, why would you do that? It's considered a billion-dollar black market industry, meaning when you farm for things and collect things, and they steal your things, log into your accounts, or create new accounts and script collecting of stuff, and they drop that off and sell it on eBay, for example. I think before I left, our gold was going for, 100 gold was going for like $9. And so there's real money behind fake gold and fake things, surprisingly. And so they're very much incentivized to rip you off, and always the Sundays. So this is a very organized group. Matter of fact, it's known that they have a building and different floors do different things. Many of the gaming people have gone over there, have been told by the authorities, there it is, that floor probably logs in or creates accounts and scripts gaming. These guys break into accounts, these guys write code, highly organized. So, and again, it's not quite state-sponsored, for sure. There's some good stuff in here, but it's pretty darn good. I have to say this is the best stuff I've ever had to deal with, and I worked for HP for 8 years and got to expose to some interesting stuff. And I would definitely consider this your typical advanced persistent threat. Now, advanced, I hear a lot of terms with malware where this is sophisticated malware. Like I heard that with all the Black POS stuff. I'm sorry, that was one of the easiest malwares ever to detect. So it is not sophisticated. Sophisticated to me is when something new occurs that you weren't looking for or thinking about. And this stuff had it in there. I'm going to walk you through it. And again, we saw new things each time they attack. Obviously, you keep learning because these persistent malwarians or bad actors or whatever you want to call them keep coming at us. It was almost like a monthly game with us. They specifically target HR with really well-crafted resumes that were infected because a gaming company just laid off 5,000 people, and they know at that point it's time to release a resume and be amongst all the other resumes that the HR person just got. My colleague had an interesting thought. Maybe this is state-sponsored stuff getting a test drive, and the stuff that doesn't get detected maybe then gets elevated up. Interesting theory, but I got no backing for that. But I thought it was an interesting thought that maybe that is kind of, maybe the Chinese or even the Russians would buy this good technology that took 3 years to detect. Right, kind of the best athlete. So here's the summary of it. Pretty typical from 2012. DLL injection, they dropped a DLL in WBM that looks just like, named exactly like one in System 32. They dropped one in Windows, so the idea here is in WBM, when WMI starts up and stops and a million times a Sunday on a server, and in many workstations, the box got infected, but nothing more than adding a DLL to the box. They dropped a DLL into the Windows directory solely so when someone logged in, it infected as well. All right, pretty typical. They dropped files in System 32 because they could. Obviously, if they're dropping files in the other two directories, they're admins. They also used the program data directory where they stored files. Why? Because it's the all users directory, right? Everybody who logs in the box has access to that area. A well-known exploit, sysprep, calling cryptbase.dll was executed and used quite often. So if you write a bad cryptbase DLL and you just tell sysprep to load it, guess what? It loads it. This is known. I've actually seen the expanding of this with executables and some commodity malware I had. Matter of fact, one of the talks yesterday with a 10.exe, my talk had the 9.exe, actually utilized this sysprep, piping in a bunch of executables. I have to write that up and send it to Microsoft because I think there's something now in exploit kits that's really expanding on that. So watch for the execution of sysprep is probably the best thing to tell you there. They had a boot up backdoor. That was really cool. They put it on our Exchange servers. It actually wrote 2 disks on shutdown after Tripwire stopped and booted up and loaded before Tripwire started. So Tripwire never saw this file. The only way we found it is, when you're in this kind of attack scenario, eventually you get around to doing memory dumps. And there it was. We had black holed all the IPs involved to a Rackspace server running Netcat just to be able to keep the communication going. And about every 30-something days, this thing would open up and phone home or try to phone home to get a connection back. It was their super secret backdoor. But it was pretty easy to find. Pointed to a file in the System 32 that just wasn't there. Pretty easy. But we couldn't figure out how to get it off disk. It was a real pain in the ass. They had data centers in Taiwan and Amsterdam and Dallas, and it's really hard to take full images and copy them over the wire. And we tried a bunch of other things, quick. We're trying to figure out a quicker way to do this. Memory dump by process was the fastest way. And turned out one of our offices lost power. Boosh. I mean, the batteries died and everything. Brought everything back up, and I'm watching these servers really carefully, trying to figure out in the course, like a couple months after this attack, what is it that this thing's, how can we find this thing some other way than memory dumps? And the server's no longer talking. The remnants are all gone, the memory dumps, nothing. I'm like, what happened? Something happened with the server. So I start splunking it, and I find the server died, rebooted. And it went down, and it was down for a long time. And I'm like, what the hell? Oh, we had a power outage. We lost everything. The UPSs were overloaded, and they killed. I'm like, oh yeah, memory only stuff. Pull the power. So guess what I did? Walked into the server room, pulled the Exchange server power, and boof, that was gone too. It was our backup. It was the one we had retired. And boom, it was gone. I'm like, awesome. Guess what we have is a new process every time we find one of these infections. Power down the apps and the databases, pull the power, and boom. So it's become part of my incident response to do that. And FYI, you really should too. Yeah. Just do it before you shut the database down first. That would be a really bad idea. And also they install a lot of new services, multiple of different names. Splunk drv.sys, right? So Splunk drv was a service, and we also right above it had Splunk. So it's like, wait a minute. And also multiple infections per machine. So they didn't infect a box the same way once. They would infect, let's say, in this particular case, there are probably 200 systems. They would infect 200 systems probably 8 or 9 different ways. One box would have 3, another box would have 2, another box would have something totally different. And they kind of littered things around, hoping if you found these sort of things, you'd miss these others. But they were all having the same logic, so they're pretty easy to find, really. So 2014, new stuff. Dude, we were just like, dude. You know, I'm an IR guy, I'm an active offender. So when I see really cool foo, I'm just like, dude, this is awesome. It's bad, but it's really awesome. Because, hey, I'm gonna have a talk out of this when we're done. But again, what triggered it? What changed? You know, it avoided the methods used before, not a new service. And fortunately, we're doing really good logging. I would have to say, as I rate all the security solutions, remember, I used to work for HP. I have seen and played with a lot of security solutions. My number one solution is some sort of good logging, proper logging. Number two, in my case, not because I like IBM, I don't work for a vendor, is BigFix. I've used it in multiple organizations, and that is absolutely the baddest ass tool. The best description of how I use it is like Mozilla Investigator or Google Rapid Response. I ask a question and all the systems have to reply back with an answer. Do you have this file in this location with this hash? Boom, and I can do an analysis in BigFix that gives it to me, much like MIG would do or GUR would do. And again, we are ninjas after all, at least we think we are. And so here's a summary of improvements. Let's walk through these. PlugX was heavily used in the initial infection. PlugX is an exploit kit. It's very modular. And so they can start off with that and then write their own modules with more stealthiness. It does a lot of automatic bypass of AV and various other tools as part of the exploit kit. So we saw that initially used for the initial infections as well as some of the littered different pieces across the environment. This was new. They actually did a DLL injection on SQL Server, on SQL servers like, you know, program files, Microsoft SQL Server, MS_SQL 10, yada /bin. And in there was this rogue DLL, and we're like, what the hell is this thing doing here? And so that was one of the last pieces we kind of went after. But it ended up injecting to the point where they could get in and compromise the SQL Server to enable XP command shell, which allowed them to do the .NET commands within the SQL Server, which was totally hidden because they know most of us don't log SQL Server to our security logs. So in that aspect, they could go unnoticed in this avenue. There is a way to do that, so I highly recommend you get your security SQL stuff into the base Windows security logs because I don't have to change Splunk, it would just automatically collect it. There are articles about how to do that, so that was the takeaway from that particular item. They had a binary infector. This was the dude. So we ran McAfee, for example, AV. We had backup software and imaging software from Altiris, BigFix, obviously, several other components, Splunk, etc. They actually had an infector that infected our management software, and the management software still worked. And we'll get to why and how that worked in a minute. They had a driver infector. Again, the way I catch these things was this really cool high-tech script. Robocopy everything in this directory to captured, only try once, and skip these other directories so I don't get these funny symlink loops. And it just goes next and goes back to the top and just does this over and over and over and over again. So we started launching that across our environment. And so as the boxes got popped and these things run, if you don't know how malware works, they drop a file, they execute a file, they delete a file. With Tripwire, you have about, Tripwire does kind of like a 10-second sampling. So if you can execute something within 7 seconds and delete it, Tripwire will never see it, okay, FYI. So they know that, and so malware generally does this very quickly. And the only way to capture it is to try to get it while it's doing its thing. So I have this high-tech method, Robocopy everything to captured, and I run this on my lab boxes, and I will deploy this as a part of IR if I think they're actively on box, or we'll clean a box so they come back and nail that box, because we know they like domain controllers and Exchange servers. And we caught these infectors, which are really cool, because then we had to figure out what they did and how they did it. Because right now all we know is we have infector.exe and infectorsys.exe. They hid stuff in the registry. They hid their scripts that they executed in the registry, and they also hid their payload in the registry. And folks, the registry is, let's see, can I do a good Donald Trump? The registry is huge! And it's a big database, so hiding stuff, it can go totally unnoticed. And surprisingly, there's a lot of stuff that can be hidden in the registry. So initially they popped a user, it was not an admin. So A, they're good. We're pretty sure, or at least I'm pretty sure, patient 0 was an Office O-Day exploit that had not been patched yet. Because afterwards, and we got some patching going the next patch cycle, some of the stuff we tried didn't work. So we're pretty sure that Word doc or thing that user got sent, he was immediately imaged, and we don't generally do that, but all the people that got infected, because it was a fast, rapid roll, he was on vacation, they just went ahead and did a bunch of systems. I don't really care at that point. I have a couple systems, and I have all the data. But generally, you try to keep that patient 0, because normally in these attacks, patient 0 looks nothing like patient 1 or patient 2. But patient 3 through whatever generally look the same in some aspects. They dropped their initial malware. They used the backup software. They harvested the backup software creds and hopped on a domain controller, and from there, blah, 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 across the environment. And they spread all over. Same MO as 2012. They always went after the stupid domain controllers. Obviously, that's where all the creds are. Mimikatz or whatever their equivalent is that they run, easily pull the creds off. Now, in this case of 2014, I'm pretty convinced that whatever they're installing on these boxes actually needs an admin to log in before they can steal the creds, because that was a pretty much almost a, hey, Bob just logged into the thing. Guess what, Bob, 10, 15, 20 minutes or an hour later just popped through more boxes. So I don't think they were harvesting right out of the domain controller. I think as people logged in, they grabbed their creds. So same MO, that aspect, same behavior in how they crawled. And so files dropped and gone, right? They used publicly accessible directories to drop this stuff. Why? Because they didn't have to worry about what user they were. They would just drop it where all users had rights. So if you're not monitoring C users public or C Windows Web or C perf logs, you better start doing it. Not to mention the whole users app data, local app data, local app data, roaming directories. And then they deleted the files fast. I mean, we're talking less than a second. We could watch them, boom, gone. But they did leave some on disk. Obviously, the persistence must remain in some way, form, or manner. And so they were gone, definitely in 60 seconds. The SQL Server being 5 deep, they dropped a DLL called cscapy. It is a DLL that's required by SQL Server, so if I put the bad one right next to the executable, yay Windows, you will load the bad one first before you go to System32 or wherever and load the good one. Yay! They drop files in sysfile64. QWave DLL is normal on workstations for sound stuff. It is not on servers, so they used this thing across the servers as one of their mechanisms, thinking that, QWave's normal. Not on servers, it's not, especially VMs. They went after the Splunk and Altiris directory where they dropped a driver, .sys or a driver. Windows doesn't log this stuff very well. If you want to log driver loads, you're going to need to use something like sysmon or the Windows logging service. And so they named it to look just like, there is no Splunk sys in the Splunk directory, by the way. Splunk DLL, yes, Splunk sys, no. Same with Altiris, so these were the same payloads. And so they littered these things across the environment looking like our management software. That was a big thing they did this time. The initial infectors, again, dropping to C users public, because again, that's everybody when they log in, they can pull this. They had an item called c.exe, infect.exe, infect sys, so this is the thing that infected the binaries, this is the thing that did the drivers. And then 64-bit, obviously, the DLL for that. Wasn't really sure what exactly this one did. And then one that was specifically named after our company. So that means there's probably a blizzard.exe and a, whatever, riot.exe as well probably out there.
Why would they name them infect.exe and infect sys? And that's just like, it's like, come on, find us.
How many people here do logging good enough that you would see this execute on your systems? Okay, I see 1, 2, 3 hands. They don't have to. Bottom line, they don't have to. They do in our environment, but they're writing this for the entire gaming industry probably. Oh, they were deleted within 1 second. We wrote an executable that wrote files 0 seconds, delete 10 times, wrote 1 second, delete 10 times in order to figure out where the threshold was. And yeah, we watched them. We actually recreated this in the lab and actually was able to record how fast it was. Yeah, won't be there long. Perflogs had the command binary stored there, and then Windows Web had a bunch of ini files for permission changes. The temp directory in Windows had the VB scripts and the AX script. And then sysfile64 had the files dropped. This was the DLL that was obviously associated with that particular infector. This guy here and that guy is a different piece of malware, but this guy here is the same as the Altiris and the Splunk sys, same thing. All the sys files were the same payload, just littered along the disk in different ways and infecting different ways. So they they pointed an actual new service in this particular case when they used this one. It was a new service on a couple boxes, thinking, oh, we caught this, and they wouldn't see the other one I'm about to talk about. So perflog, c.exe, yay! For once, we got their creds. So if you look at this, you look at this slide here, perflog CXE is being caught executing, and here's the command line, obviously port 445, and we caught their password. So now we had the ability to actually go to their command and control server within our environment and see what it did. So hey, winning. Thanks for the port and password for once we compromised them. So now who's sophisticated? Persistence was really cool. In this case, they created a driver. In this case, this driver, again, same payload as Splunk sys and Altiris sys, but in a different location. But they pointed it at program files, common files, you know, WLX sys64 sys, but it wasn't on disk anywhere. Couldn't find it. It's like, why would they modify the service DLL in this particular, by the way, it was the worst CPL support. So who needs Windows error reporting when they're infecting your box, right? They didn't want to use it. They didn't want us to see it. Not that anybody monitors anyway. So they pointed this thing here and we're like, oh, why? What good's that do? There's no file. And we're like, oh, okay, we know what's going on here. Something we're missing. And so this is what it normally looks like right here. So they modify that entry. And it turns out that this is what the entry looks like after they messed with it. So it actually isn't that. It's pointing to some obfuscated code, right? In some cases, mistakes, they left it as an MZ. In some cases, it put it in hex as a 45A. But in all the successful infections, it had been encrypted in some way. And so all we knew it was a big payload. So how did it load if it was not on disk? Well, yay, Windows support, CPL failed to start. Yes, thank you, Microsoft. Flaw number 5,425,000. When a service fails to start because of a missing binary or whatever they point to, it loops. It doesn't try once, twice, 3 times a lady. It just keeps looping and looping and looping, which means you got lots of time to get that file there, right? That's the key there. And yay, you know, thank you there. But once the file existed where CPL support started and the system was now infected, and then the file immediately disappeared. We're like, what the frack? We still hadn't found the file. And we knew because it was a sys file, we were pretty confident it was probably the same binary. That was our assumption. But don't ever make assumptions other than help you go a direction when you get stuck. Let the data do the speaking. So when we actually hashed the file, they were at the end the same file. All the drivers seem to be the same. So again, persistence after leaving the key files behind like they did before, well, at least one anyway. C users public 64.sys started telling us some information. I'll tell you how I caught this here in a second. And then, of course, referencing the Windows. So if you ask how I caught some of this stuff, this is how I did. Now, if you haven't figured it out by now, this is Commandline Logging that now is built into Windows 8.1 and 2012 Server R2 if you tweak a key. It is on Windows 7 and 2008 Server. At this time last year, in February 2015 of this year, Microsoft added a patch. It's KB 343.75. If you do not have that patch, I highly recommend you go put that patch on there. You tweak the registry key, and you start collecting this with a process create 4688 event. So those servers that, and I had been playing with this up to this point, one of my summer projects was to get this command line logging going. So a couple Win8.1 boxes we had, and a few all the new servers for a new game we were doing were all 2012 servers. I started turning this on to see what we do. And I started building Splunk stuff. I hadn't quite refined it yet. But the cool thing was anytime command line was executed, if I went net use, whack, some server, whack, some user, whack, / password, whack, it's in the logs. I don't worry about having passwords in the logs because I just tell the developer, hey, take the password out and do it through a file or something so we don't see this. Or I can tell Splunk not to even collect this particular string, which is an even better way to do it. So I don't consider it a problem collecting command line logs. I can remediate that problem. And so I started collecting this information as we started looking at the boxes that were infected, and it's pointing me to locations that I now have to monitor or look for across the board using a big fix analysis. Hey, do any of you servers or any of you boxes have 64.dll in this location? And boom, I get a response back in about 15 minutes. Do any of you have this file here, this script in the temp directory, et cetera, et cetera? But the other thing it did is point us to software clients. Like, wait a minute, that's a reg key. What the hell? And so we went looking, and basically we started seeing some interesting things in the registry. In this case, the command line logging was the key, and I just told you about this. And we have a big fix thing that looks for several, a whole list of admin utilities. If you want to look in the Windows Splunk logging cheat sheet, you'll get a short list of a lot of them. There's several more I have. It was just I was trying to make it short enough. And basically when that thing gets triggers, we get an alert because of the multiple executions of that. Yes? Oh, you having a problem? Sorry about that. If I'm doing that, just somebody do this. Wave your hand and go. I'm trying to hold it against my body so I can keep that going. And so what we found is, and this is where hackers don't look anything like admins, is an admin will go to a box, type netuse, maybe run cscript on an exchange box to clean something up. A, it's always an exchange script. B, it's always this script or PowerShell script. And C, he's only doing a couple commands. But in the hacker's case, they executed cscript. They executed stuff about the registry. They executed net stops. They executed command.exe with cscript. They executed a push D, which is changes a directory, not a heavily used command in Windows, but it's there. They also did take own, because now they're trying to take ownership and hide the DLL from us. They hit them, attributed them, and all that. And so right there, the quantity I got just from this one infection allows me to set up a logic of if all these executables in my list execute and are greater than quantity, say 2, that means on the third one of these, my Splunk would alert me to multiple commands being executed in a box. I rarely caught admins doing this unless they were installing a new system, and I can just reach out and say, hey, is this you? And so when they started doing this in the boxes we had command line logging, it lit up like a Christmas tree. It was like win, 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 win. Yes?
Do you think that they're going to be able to get command line logging in Windows 10?
It's already there.
Oh, okay.
Moving forward, it's already there. Yeah, and on. All the Windows stuff now has this option. You just have to tweak a reg key. And so it's in the Windows logging cheat sheet, the reg key you have to add. Does it get a ding? How can you ding dong?
I'm gluten free.
Ding coming. So hidden in the registry via the command line pointed us, hey, look here, software clients. There was also a software classes key they used. And the classes asterisk, even better yet, really trying to hide it, not making it a name. And inside this was a bunch of info, one of which was in this funny scenario of this big blob. We're like, what's up with that? Right now, I still have no answers. They pointed me where to look, but I can't read anything. So, we kept poking around, kept poking around, kept poking around. And in some cases, especially when we started recreating this in the lab, because there's different stages, they literally copied the driver out of the file system and dropped it into the registry, so it was MZ and all the normal code you normally see. And then in the course of their infection, they would convert it to hex as part of their obfuscation, and then from there, they encrypted it. So when we did see these in MZ, we could harvest them. When we saw them as 45As, we could harvest them and turn them into MZs. We could hash them, and now we knew what was hiding in the registry. And we didn't care about the encrypted payload at this point. We knew it was that driver. And so that led us to the fact that in this case, here's the big long script. That's what it looks like when you're looking at it. I don't know what that means. And so you have to start trying to get clever and figure out how to harvest it. This was new. They've never seen this before, and it led us to actually changing some of our behavior in doing IR. They added 3 new keys to the registry. They put them in the software clients or classes key, again, trying to hide in multiple ways. And they also, on the HR system, created what looked like a Adobe Acrobat file. It was the same driver. We don't believe this instance actually successfully installed. It failed. And it's a good thing because this person was infected months earlier. But it definitely hung. There was something that did not work in their environment. They created 3 keys in English: put file, file, and read. And here's what was in them.
Yeah, was that DXC on purpose or EXE?
No, DXC. That's not a typo. That's what they named the key. Who knows?
Okay.
Yeah. But in there was the driver. And for sure it was an MZ. It was a PE, Windows PE file. What's that? Yeah, they love Adobe apparently. But yeah, that's the name of it. You can't go off a name.
It rhymes.
Yeah, true. So in the put file directory, they had this big blob. Again, there's not much there, but that's, actually the stuff they were doing. And then in here, you can actually see one of the ones it was done in hex. So this is the one I harvested to figure out what it did, because if it's in hex, I know I can make it actually into a PE, and then I was able to hash it and see that it was indeed the same driver as everything else. So we now knew what the thing was that was infecting the box, the same as all the others. And then, and again, if you don't know, 45A means MZ in hex. Whoops. And then they had this read key. So in essence, what they did is they had the infector reach out into the registry after it was populated, grab this registry key string, which was the actual script information, to infect another box. Then, in order to do the de-infection or the pull out of the registry and write to the disk, they did the put file where it actually told them how to pull it out of the registry. It was all the C script and whatnot that then wrote it to disk. And so their scripts are in here, again, obfuscated, but in some cases not. And then the big-ass file payload was a 296 meg file payload of a driver. And I'll talk about that in a second. So the infector, again, was for the DLLs to infect McAfee Framework service. McAfee Framework Helper, sorry. Let's make sure I get the right one. And the infect sys was the thing that did the driver infection. So we actually used these tools in the lab and said, yep, that's what it does. And it infected the McAfee Framework Service, the BES Client Helper, and several others. And some they failed, I think by accident, or maybe this tool doesn't work on everything, but we tried it with a lot of others, and we were able to infect and run Notepad, for example. It was surprising. This infector works really, really well. And yep, yeah, it worked. And so now we could recreate the payload in the lab, which means we knew everything we needed to move forward. But one thing, how did it get from the registry to the dropped file location? And well, here it is. There's the location again. Once we executed the malware and saw that McAfee Framework Service was doing it and checked the hashes against all the others, we found the systems that we had the initial artifacts on, they all had these different hashes for these different management utilities, and we're like, aha, they popped them. But they still worked. AV still worked, BigFix still worked, Altera still worked, Splunk still worked. I'm like, what the hell? This is really cool. And so that came up with it, dude. So as soon as it loaded, it deleted. So now that the compromised binary loaded, read the key, decrypted it, dropped it to disk, now this looping service could read that file, load it, then the thing said, okay, you're done, delete it. So that's the way they tried to keep the persistence where we couldn't find the file. And of course we were better than they were, so yay, it worked really well. So what led us there? Malware discovery, I talked about the concept of baselining. In order to figure out where these binaries were, I said something on the disk is different. So we immediately initiated, I have this big master hash of Windows 7, Windows 8 I had to add to it, and Windows 2012 I already had from all the other servers that were built, and Windows 2008, I had run a baseline hash on our new builds. So I had this big ass file. And I threw that in comparison with SHA-1 with a -X to one of these infected systems. I just made a script with BigFix and pushed it out and said, run this, drop the files, and I went and harvested them. And what I found was in the BigFix directory, in the McAfee directory, in the Altera directory, is one binary had a different hash than all the others. And at that point I went, I'm gonna go look across the environment and hash McAfee Framework Service for everything, and then I'm gonna sort it, and I see, hey, all these have a different binary than all the rest. Hey, there's those tidbits, and that's how I went across the environment and found them. And so now I knew exactly which machines were infected with that particular mechanism. And that was good. And you do the compare. I call this a master file repository, MFR. And so I do that compare, and it showed us those single hashes, and that's how we basically do it. If you're an IR guy and you've ever done this, SHA-1 but this recursive hash stuff works pretty well. We looked about them, and again, now we're winning for sure, because now we know exactly the missing piece of what to do to clean it up. All right, but I want to see it do it. So everybody's familiar with Procmon internals tool for Windows. Well, there it is actually doing it. So there's the BES client helper doing a create file, C program files, common files, system, WLS64 sys. And there it is actually writing the file to disk. That was the final absolute. We're certain that's what it's doing. So pretty cool. And then further down, you can actually see where it deletes it. Bam, got them. And we now know what we need to know. So finally, we had all the pieces recreated in the lab. High confidence for remediation now able, and this was about mid-December, and started just before Thanksgiving. And it did not take 210 days mean time to detection. This was literally within the first couple hours, contained within the first couple days, and basically at that point, remediating. You can't just turn off game blades in the middle. You have to do maintenance windows and all that crap. There's nothing of value that they can take on those, so it didn't really bother us too much. They were contained, they couldn't phone home. But once we had everything, we turned off all the communication. We were certain we had everything we needed, except for the fact that one of the blades unfortunately had crashed before the cleanup, and so when the guy found it had crashed and brought it back up, reinfection. So warning, be sure to work with your guys. Make sure all the drivers of all the management apps are running before you start your cleanup, and account for every damn system. Because you skip one, yeah, you gotta start all over. Fortunately, same stuff, so we were able to immediately cut off the communication again and start over. And this time we went through a lot of validation to make sure everything was running before we cut everything off. So yeah, it worked pretty well. So
how far was it from when they actually first got in until that point?
how long was it from they first got into a cleanup
Infected, you could find it immediately, but how from first infection
to begin a remediation? So we detected it within the first couple hours. We remediated, yeah, good question. We remediated it we contained it in the first few days. We cleaned up enterprise probably in a few days later until, of course, that box came up. But we had a lot of other components we could not clean. We're talking hundreds of freaking game servers and all the components, all the other Helvel servers. And because they're internet facing, there's no firewall controls like you would think in normal environments because of the throughput. We didn't have the same ability, so when we cut stuff off, we had to do it, all at once because of all the different data centers across the world. So that was scheduled. They weren't able to talk to any database servers, so we didn't worry about risk of that stuff. It's more of them just trying to hide all the persistence and being able to hop around and go looking and getting all the stuff they actually want. Gaming has a pretty well-designed infrastructure, and so there's nothing of value here. Let them have it. If it's not crashing the game, don't worry about it. If it crashes the game, rebuild the server or push it to another one. So good question. It probably took about 2 tries of 2 weeks to get all the things cleaned up. The rest of the stuff that was contained in the bubble. So malware management allowed us to set up the alerts because I constantly read these reports. I recommend you do too. I take the tidbits. I'm not looking in the fonts directory. I pick on that one because these guys use the fonts directory to store their log files, their debug log files. This ran, yep, successful, and it was very detailed. It was awesome. So they forgot to delete them. But I wouldn't have found that if I wasn't monitoring the fonts directory, which I actually got from another APT. That's how malware management works. Malware discovery, because I'm hashing the boxes saying, there's something on here I'm not seeing or I'm not looking for in a directory they're using that we're not managing or monitoring for, so I've got to hash the whole box. So that's what malware discovery is involved. And then malware analysis and doing it and recreating it in the lab gave us all the assurance we knew we could remediate very fast. So how you can detect this, ninja tips. This is how we harvested the malware. So some infections hung. So recommendation number 1 is look for parentless executables. So or parentless processes. For example, in the talk yesterday and also in my training, we referenced on one of my slides a malicious Word document. In that Word document, when you launch it, there's embedded macros and VB scripts. So you have a tree in the process tree looking like this. It's WinWord, it's command.exe, it's C script, it's PowerShell, it then calls another command.exe and some other executables. And so you get this tree structure. You close Word, command.exe is still there, but now its parent's gone. So I can crawl through systems with a simple script. Some sysinternal tools will do this for you and basically find all the PIDs running and then say who's your parent, because there is a process structure within the Windows and you can identify that. And show me all the parentless identifiers. So when the stuff hung on the box, yeah, the parent was gone because the infector launched, assuming it would complete and delete it. When they hung, I was able to go harvest. I knew those servers had something on the box and I went and harvested it. So that's a big tip. This was really valuable for us, is look for parentless processes. There's not a lot of them normally. Some stuff like Java will do it, but there's not a lot normally. The other thing is the command line logging obviously pointed us where to look. So we created these really cool high-tech scripts with the Robocopy. Here it is. Nothing more than woohoo. I changed it just better for Prezzo, but it was captured. I use the word captured. But I exclude the directory capture. I don't want to capture my captured stuff over and over. And literally it just copies everything, loops. So we turned this on all those directories I talked about earlier. And the cool thing was, as these things ran, and when that second infection happened, after we were doing cleanup, so as we did cleanup, one of our steps was to launch these scripts and just let them loop. And these directories are pretty much empty. There's not very much stuff in where they put this stuff. And so these things ran really fast. Nobody even noticed they were running. And so when we got reinfected, we got so many binaries out of this, it was great. Yeah, simple, high tech, right? But it worked awesome. If you're in a lab environment where you're taking payloads and you're infecting them, highly recommend you do this where you think the malware will drop. Obviously, it won't catch, don't do entire C drive, that won't work. But directories that don't have a lot of stuff, this works really well. And anything in the app data space for all that commodity user-based drop malware is awesome. So, top priorities. Here's the KB. Guys, everybody needs this patch. Read this. It also tells you about the registry key to tweak. I call this, some people have mentioned, I've seen my Sexy 6 talk. This is kind of an elaboration on that, especially because of my Sexy 6, and that was built to pick on Home Depot and Target. Target obviously got popped, we know that. The iSight Partners report showed in much detail that here's what it did. One of the things it did was drop 2 services, blackpos.exe and POS.WDS. If all these retailers, Home Depot especially, had monitored for nothing more than, and this is XP, these are Win 7 and on, Vista IDs, but there's an equivalent. If they had monitored nothing more than a new service install on a POS, they would have caught this thing immediately, if that's all they looked for. That's a huge payoff here, folks. If you're not looking for these 2 items right here, this is your short list of stuff. Process create, you have to turn this on. It's noisy, don't get me wrong. Read the Windows logging cheat sheet to get some guidance. But if you turn this on, now everything that executes in the system will be recorded in the logs, in the Windows logs. 4624, successful logins, of course. 5140s, this is where I'm capturing them net using to boxes and pushing their payload, which they then executed remotely with WMI. 4663s, I have auditing on file locations like App Data Local, C Windows Web, C Users Public, and C Perf Logs, because nothing ever happens there. It's not noisy, it doesn't fill up the logs. So that got turned on. And because malware management tells me these locations are often used, I do some testing. How much is this really putting in my log normally? That's a good alert. I'm going to leave it there, and now I can catch file drops just from logging. 5156, if you don't use the Windows Firewall, another talk yesterday talked about this was huge value for them. Sysmon will also do that if you want to use the Sysmon service. We did use that as part of the IR here. Put it across a lot of servers, the Windows 7, 2008 servers. It stopped a lot of times, so it wasn't as consistent as I'd like. Apparently, Carlos Perez has talked to Mark as well. We're both noticing some of these bugs, so they've got to work on version 3. But if you're not doing it, if you have, for example, the Windows Firewall disabled in the root OU, get rid of that. Get your guys to move it to a sub OU, so that way if you need to turn the Windows Firewall on, you can drag the system out of that OU, drop them into an OU that's got all this stuff turned on, and now all of a sudden your logging will get really enhanced, and it's nothing more than moving the machine to a different group. And put it in any. You won't block anything, the user will never know, and now you can start collecting all this information. Highly valuable. New service in the case of WinNTI 2012, the change service where CPL supports, it's a change, so it's a 7040. And if you're doing PowerShell logging, you do need to have a default profile. Yes, there's a bypass for that, I understand that. If you just execution policy bypass and no profile, you won't get this to work. But if, as your people use PowerShell normally, and you set the remote signed execution policy, when scripts are executed, you will catch what the command lines are if you enable this. There's a couple of variables you have to put in. So these are your top priorities of things to start with. Yes?
Am I mistaken, or is there the log on failure 4625?
There is. Failures don't do me a whole lot of good. They're very noisy, and these APTs rarely, 4625 is the login failure. He says, wouldn't that work? It's very low value to me, honestly. Surprising. Internet facing, yeah, higher value, but you're going to fill up a lot of failures. I'm more interested in that SAM connected to his machine, his machine, his machine, his machine, his machine, because we know just from their behavior, they pop the creds, they know the creds. Failure is not an option for them, it turns out. And so just very little. Now there was some times where commodity malware will try to brute force. Matter of fact, some of the malware reports, one of them has a whole big list of the top 1,000 bad passwords that it brooded. So yes, but be prepared to have a lot of noise if people are actually doing this with failed logins. So that's a good question. It is in the Windows logging cheat sheet, but just be aware it's not my highest priority. Here's an example of that big list of commands. IE exec should be in here as well. It's not on my sample. I had to take a couple out just to shrink it to make it readable. But here's kind of what my Splunk or any log management. It's event code 4688. Look for all these and then think about it from the perspective of, well, I execute some of these all the time. You won't do it in the quantity you see in the tags. No way. You just won't. Size matters. So this was a big one. The fact that this payload got dropped in the registry, it turns out if you scan the registry for keys bigger than 20K, there are only about 20 of them. So if you filter those out in a whitelist in some way, and you look for large keys, the WinNTI was 296K. And so my buddy had written a little script, and we ran it on all the boxes, and now we found every box that had large keys, and then we filtered those out as the ones as normal, like your icons and all that stuff stored. That's a big key, for example. And Microsoft stores all kinds of status in there. Yeah, you can find this stuff pretty well. There is a GUI version, Reg Scanner from Nearsoft, and then David Longnecker in Austin, one of my Austin peeps, through some conversation of Twitter, went out and wrote a Python script to actually do this. I think the default's 20K to look for large reg keys. We are also incorporating this functionality into LogMD. This is a big one where I want to replace using a GUI. So LogMD will actually do and provide you a whitelist for large reg keys as you use moving forward. Enhanced logging, Sysmon, if you haven't played with it, please do turn it all on, but warning, somebody noticed this yesterday was using it, you must exclude Sysmon from your AV or it will kill your box. Because now as it's registering all these DLLs and drivers being loaded, which is boatloads, AV can't keep up and your system will just come to a screeching halt. So there's my warning to using Sysmon with the monitor logging, with the network logging. And again, the Windows logging service is Sysmon on steroids. Yeah, his thumbs up over here. I can't speak enough, but I've had input to this. Jason McCord has added PowerShell command line logging. He does it at the trace level, not the logs. It's actually a replacement to your logging agent, and he's doing it trace level, not reading the Windows logs. So if you want to do both, great, and it sends it to a generic syslog server. He's also, with the next version, I'm proud to announce that he's doing WMIC commands. So if the bad guys are launching WMIC, you're going to be able to see the calls that they're making. So at least maybe now I can see if they're using that functionality, I'll see that. But a lot of the hackers have moved to the PowerShell execution of WMI, and that's a different problem that we have to solve with the future project I'm working on. But yes, enhanced logging, please take a look at these. Malware discovery, I can't speak enough about how well it worked. Again, simple. You have a suspect system, so go get a good system, hash the hell out of it, and run SHA-1-Deep. LogMD will also have this functionality to replace SHA-1-Deep. That basically allows you to compare a suspect box to a good box, get a short list of hashes to look for, and help you find the bad stuff before they get too far. And how many people here have a log management solution? Yeah, so what? You don't have a log management solution? So real quick, that intermission was to call my colleague up. Introducing LogMD, this is a tool that we wrote as an outcome of dealing with this kind of crap. I needed a command line utility because there were cases where I don't have log management. I do some IR on the side, and I wanted to speed up my lab analysis. So with this, we wrote a tool, and it's called LogMD. It's at log-md.com. There's also a link to my website, malwarearchaeology.com. It's free. Please download. It dumps a report to, yeah, we believe in, and the community needs some of this basic help. We're future developing it with some other stuff. That may be a small costed item because of the development required. But it is based on enforcing you to run and use the Windows logging cheat sheet. When you run this the first time in a box that's not properly configured, what I say is properly configured for the Windows logging cheat sheet, it will fail, and it will not run until you properly configure the box. I'm not going to collect something that's going to be garbage, and Windows by default collects nothing that's of any value. So once it's properly configured, boom, you get a spreadsheet. When it does fail, you get a nice audit report of all the settings, what they're currently set to against your machine, comparing to the Windows logging cheat sheet, and also comparing to the Center for Internet Security, and tells you all the reg keys to tweak and the profile for PowerShell and the variables you have to set. The idea here is someone says, I have an IR report going on right now. Can you help us out? Well, do you have logging? Do you have this? Do you have this? I don't know. No. I can send you this executable, get your guys to get it running, send me the results back, and then I can bid on you. And depending on how long you take, will depend on how much I charge you. You should be able to do this in an hour. If you take 2 or 3 days just to get these settings turned on, yeah, my price for you just went up, which means it's going to be really hard to work with your people. So it's really good for that kind of thing. That's how I use it. It's a great customer qualifier. It will help you assist in tweaking file and registry auditing as well. So as you turn this on, one of the things we collect is what you're capturing in the logs for file and audit registering. So, example, I go and turn on auditing in the services key, and I let it do all subkeys. The TCP/IP key is very noisy. A couple others are also noisy. That's too much data. It's not ever going to help me, so I'll go turn off auditing in that location. So now the amount of data I'm putting into my logs just shrank, and the stuff that's in there is more actionable for me. And it will help you do that too. Also with file auditing. Oh, I turned this directory on, way too much data. I'm going to go turn it off here, here, and here. Ah, that looks good. Because you can't audit everywhere, file and registry. You just can't. You have to be selective. How selective? Use malware management to guide you.
If you just, in the recording of this, tell the Chinese to put all their new code into TCP/IP.
You look at a different way for that one, but maybe. No, you really couldn't. But yeah, again, large reg key. That I do everywhere. So yeah, we have multiple ways of looking at this problem. And then once the system's configured, you clear the logs, you infect the system, you run LogMD, and then you view the report. So Excel spreadsheet, yes, I understand. Use the filtering, it's awesome. But again, we just started this project in May, and it is free and released now. That's pretty fast, and it works pretty well, as I showed some people yesterday. Anybody in here play with it yesterday? Or at least look at it and saw what I did with it? Shout out what you thought. And then, again, the audit report for you auditors or somebody that says, well, I don't know what I'm set to, but I just want to see, run it, get the report out of it, add it to your assessment report. Or if you're a consultant, use it to say, hey, I want you to improve your logging, and here's how. I did contribute in the Center for Internet Security Benchmarks years ago when I was at HP, so that's why I know some of the shortcomings of that. three whitelists. So I run this thing, I've got all this broadcast traffic, I got all this normal printer traffic, for example. Great, we give you a whitelist to get rid of the IPs that you don't want. Source, destination, destination port. So you put that in there in any combination and it will filter that out of the results. It does not just drop them, it puts them in a whitelisted report. So you're not losing any data, you're just moving it out of the main report into a secondary report. We also do it by process command line. This command line conhos, blah, 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 I never want to see that. It's never a value, whitelist it. This particular command line, the search indexer, never want to see it, whitelist it. And so you start chopping away at traffic by using the whitelists. In a lab, my run of LogMD on my lab box is almost blank because I've whitelisted all the normal stuff that happens in my lab. So when I infect the box, I'm pretty much seeing all the interaction that the box is doing within that malware. And then again, process name, don't do that overly random. Make sure that if you're excluding by process name, make sure you'll never see anything in the command line that's of value to you. Because if there is at some point in the future, like you would want to get rid of sysprep because all those sysprep command lines would be of high value. So be careful when you do it by that. Do it by command line first. Only if process name by, like I exclude process name LogMD. Only do it when you know there's never going to be value. File auditing, whitelisting as well, so that way, as I'm looking for those reg keys and I'm trying to get rid of some of that noise, and I'm turning on auditing, and I'm kind of doing it quickly in an IR scenario, I can whitelist those out of my results. And then that whitelist becomes what I use to refine Splunk and blacklist the stuff I don't want to go to Splunk that's noisy, but I do want to collect. Stuff like that. And then the report itself. So here's a typical crypto event. Someone brought a laptop in and said, hey, I'm cryptoed, so here it is in yellow. Not something I ran, it's a box that was given to me. There's the execution of the Cryptolocker stuff. It immediately copied to a different file name. It went through the deletions, spit that data out to null, same file name here, same file, same here, so it's saying delete me, but don't tell anything about it. And then, of course, right after the Cryptolocker, it executes a VSS admin delete all volume shadow copies. So you now know restore is or rebuild is the only option here. There is no volume shadow copy option to restore from. And so that fast, I know what to do with the box. Boom, done. And that's pretty much, you can see the lines 40 through 72. There's not a whole lot of data in this. So it works pretty well for that kind of thing to investigate. So here's a Word doc I exploded in the lab. There's the Word doc being executed. Here's the batch file that dropped out of the Word doc. This is the thing that the guy had yesterday. His was 10.exe and this one's 9.exe. It's pinging China because it wants to make sure it can communicate or it will kill. So I've tested that, and it kills if it does not complete this. And then there's the 9.exe executing all over the place. There's the ping once it's done, only once to see, yep, so it still can communicate. And then boom, I move over in the spreadsheet, and I now can associate through the Windows Firewall logging, 5156, I can see the cool thing about Windows Firewall logs is it tells you the process and the IP port and protocol it uses. So here's WinWord talking to an IP. This particular IP is a DreamHost server. I'm sorry, but Word, much like PowerShell, should never talk to any IP ever externally. WinWord should never talk to anything but Microsoft. So immediately that got added to our bad IP list. And then cscript ran, we have some more IPs. And then there's the ping running, and then there's the 9 and sysprep running. And so I'm harvesting these IPs, checking them with whois so that I can see what company and network they belong to. I add them to my into my bad IP list in Splunk. I run it. Anybody who visited those IPs is now infected. I can immediately remediate from that information. And this took me 15 minutes. Bink. I did that in a whole whopping 15 minutes. So it speeds up that kind of process for me. Again, it would take a little longer for the advanced stuff because I have to pick it up from here and collect it from there and put it in here, reassemble, reboot, and all that. But this helps a lot. This was really shocking how well this worked for me. So that's why we're sharing it. It's kind of one of those, hey, this thing actually works. But yeah, really, really well. So in summary, malware is noisy. We can detect it. Logs hold all kinds of information if you just go out and enable and configure them. And the Windows logging cheat sheet, there it is, what it looks like, 6 pages of gold. Talks about how to enable, configure, gather, and harvest. Enable and configure, self-explanatory. Gathering is what you can do it like command line with PowerShell or W-event util, command line utility. And harvesting is talking about how to put it in a log management in regards to the sections. And so please go do that, as well as get the Windows Splunk logging cheat sheet to help you out with your Splunkage, to get you started if you're not doing those kind of security alerts. And with that, here's some resources. MalwareArchaeology.com also has a tab to LogMD. Log-MD.com will be a new website next year. Since this thing works well, we're actually going to split it off. And here's where we get the stuff. Pretty simple. If you Google this, pretty much Google will help you autofill archaeology because you can't spell it. And you'll be able to find me real easy, actually. Also on SlideShare, you can find me through that as well with malwarearchaeology.com. And with that, I'll take any questions, and Sam will throw ding-dongs. Questions? Got one right here.
Did you say you got the credentials for the community?
We did, within our environment.
Oh.
Yeah, they set up a box, and it was talking to that box. It was how they communicated with it, and so we used them, and we were able to get in saying, aha, boom. We focused on that box. Ding dong, yes?
Before LogMD, how were you pulling these host logs?
So before LogMD, how was I pulling these host logs? In the environment in gaming, I had Splunk. Unfortunately, sometimes we had to go to the box remote, or I would execute BigFix scripts, just basically scripts that would collect information specifically that I was looking for with some of the tools that I have that I talk about in my malware discovery class. Before that, very manual. So I've got like a script that I run Reg Scanner, and a GUI pops up, goes look for big keys. So we ran that across the environment. Reg Shot to capture the shot and try to compare that to others. A very manual process of just executing a lot of sysinternal tools. So LogMD, I'm trying to write that to replace some of these more clunky mechanisms. So in theory, you could use SSEM or whatever agent or netuse, PSExec, or however you want to execute this executable, throw it on a bunch of boxes that are suspect, run it, take the output, collect it, and then you get rid of a lot of the steps that we're doing very manually. This is kind of the manual way RR people do it. Manian people would use Mir and a lot of these tools that I'm using, but a lot of IR guys kind of do it this way. Just very, unfortunately, manual. Unless you have something, big and fancy. Yes, any other questions? None? Going? Do I run into malwares that try to disable logging? Good question. Surprisingly, the only dumb things the Chinese did in 2012 was somewhat clear the logs. It's clear they had a noob running along with an expert. A lot of mistakes on these systems, no mistakes on these systems. If you're using log management, the stuff gets sent to a log server. They can mug up the local logs all they want. If they turn something off, we get alerts for that. So if you start messing with turning things off, we get alerts. So that we have to look at the condition being normal. Have they or do they or have some things hung, or whether it was them or not, happen normally? Absolutely. But we have is Splunk running correctly? Is BigFix running? We use each product to look at each other product. And so we have this cross thing saying, is Splunk running in BigFix? Is BigFix running in Splunk? And we kind of keep that stuff up to date. So yes, I really not, because I don't think they want to trigger the there. Carlos always says, I got you to click on the email, and now I got to gather as much information as I can, figure out how you're doing it. And by the way, his recommendation in his prezo at DerbyCon was referencing the Windows logging cheat sheet. And he said, if you want to catch me, you need to do stuff like this. If they go after that, if Carlos, let's say in a pen test, starts going after that, yeah, you got to look for the conditions of clearing logs, of stopping of services. And I do automatically monitor that. You saw the 7045 and 7040 in there of new and stuff. So good question. I wish it was that easy. They don't seem to do that. And normally when you see the behavior of them getting to that box. So can't you just rootkit the box? Sure you can. But how do I get to the box without making any noise in any way, putting something on the box, getting it executed without doing any of the stuff that you saw me collecting in the logs? It's really difficult. Windows does a pretty good job of collecting stuff. I mean, really there weren't any gapping holes in all that APT we saw. I've just never run into it where, wow, we're missing a lot of data. Tripwire, missing tons of data. But logging, built-in logging, not so much. I love Tripwire, by the way. It's just you have to understand its use, really, like any security tool. Yes? So after they infect the box, it phone homes. It turns out these guys, these actors, that's a really good question. I didn't mention that in the talk. When they infect a box, it doesn't necessarily phone home. They are heavy users of Timer, the Timer API, to where they will infect an environment and wait until we're gone in the day, and sometimes these things wake up at 7 o'clock at night. So once we understand the IPs, we can watch their behavior. And they're very much opposite us. Either the Russians or the Ukrainians or the Chinese over the ponds, either direction, they're opposite us. And they really do most of their work at night because they know we're offline, and there's a better chance of them getting further and embedding themselves faster without us watching them. I would say 80% of the work happened off hours and did not phone home for at least hours, days, or in some case 30-something days. They were really good at just not making a lot of network noise for that reason of us looking at network traffic.
For the gaming community, if an account got compromised and they lost items, did the company reimburse that person?
Yeah, the logging that goes on in the whole gaming platform environments are very detailed. They collect a cajillion pieces of information. They can tell exactly when, what, who, where, what, all that stuff. And they will restore accounts. Very common.
A couple of years, a person, they sued the company or a company because he got compromised, lost it all, they wouldn't reimburse him.
Yeah, it's probably because it came from his IP, probably. They know that, and if your IP is compromised, it has to come from another IP from another country for them. Gaming's really good at that.
So I'm just saying, I'm
Yeah.
just making sure that the gaming company can move forward and,
Yep. Any other questions? I'll be around. Talk to me. I've got the big BSides shirt.